Hello again and welcome to another GCSE Computer Science theory lesson. This video is going to be on Unit 5 and we're going to be talking about the 4-layer TCP over IP model. So let's get started with the key facts that you need to know for the exam. So in the exam you need to know that there are 4 layers. The top one is the application layer, followed by the transport, network, and then finally you've got your data link layer at the bottom. So you need to know all 4 of these layers and the order in which they go in. You also need to know about which protocols are associated with each layer. So it's just a simple case of having to remember all of this information on this slide. In addition to that, you need to be aware of a brief description for each layer. So, for example, the transport layer is defined as where communication is established, and the network layer is regarded as the place where devices are addressed. So only these points in red are the ones that are likely to be asked in the exam. They could potentially ask about the application layer, but it's unlikely given that the explanation of an application layer is pretty much in the name. So the description of an application layer is where applications and programs work. So, it's kind of named what it is. And for the data link layer, they won't ask you about this in the exam, but if you're interested, the data link layer is very close to the physical hardware of your computer. It's protocols concerning things like wireless and wired connections. Okay, so you can stop watching this video now if you wish. There is nothing more than you need to know for the exam. However, this is a confusing topic. It's a lot of theory to remember that doesn't make a lot of sense. So if you're interested, you can carry on watching this video and I'll talk about this layer model in more detail. But if not, feel free to stop. Okay, so let's move on to a diagram that I've done in Microsoft Paint just for you guys. Righty then, so you might have seen this diagram before, but I've made some changes to it. For example, there is now a wireless connection in between computer A and the switch, and there's also some IP addresses assigned. Now, before I get into the 4-layer model, just one thing I need to make clear to you guys. If computer A were to send a message to computer B, it would not be sending information directly to this IP address. It would be sending information to this IP address first. So whenever computer A wants to communicate with computer B, it needs to communicate to the router first, and then the router will pass that information on to computer B. Okay, so going back to this 4-layer model here, we're going to start off from the top and work our way down. So starting off with the application layer. Let's imagine that we are sending an image from one computer to another, or a picture from one computer to the other. We're going to be using the File Transfer Protocol, or FTP for short. So let's start off with the data that we're sending. So the data we're going to be sending is just going to be ones and zeros, or a fraction of an image, because fundamentally all information, whether it's a picture or some audio, is going to be represented by ones and zeros. So this is our data, and we're going to wrap it up inside the FTP protocol. So this is now going to be an FTP packet. And that's why they use the term packet, because packets, they're wrapping things up. So this data, this image data, is going to be wrapped up in an FTP packet. So here's our FTP. And I just want to clarify that in real life, this is fundamentally some sort of binary notation that means FTP. So it'd be something like this. But for the purposes of this analogy, I'm just going to use the letters FT and P just to keep this example simple. So we've got an FTP packet because we're transferring a file from one computer to another. Next, we move on to the transport layer, and we need to decide if we're going to be using TCP or UDP. Well, because of the nature of sending a single image, we don't really care about speed, but we do care about it arriving on time. We do care about it arriving intact. So we're going to go for TCP. So we're going to wrap this up in a TCP packet. And then next, we're going to move on to the IP layer, or the network layer. So we're going to wrap this up in an IP packet. And for this example, we're going to be using the destination address. So the person that we're sending this packet to, that's going to be what the IP packet is made out of. And in this scenario, we're sending to this router here. We're going to be sending our picture to this IP address, which is 87.32.12 and 1. And just something I want to clarify with you. All of this stuff, whether we're talking about this FTP bit, the TCP bit, or this IP address, fundamentally it is all going to be binary representation. But for this example, I'm just using decimal and characters. So now we've got our IP address wrapping around the entirety of our packet. We now need to think about the data link layer. So that's whether we're using Ethernet or wireless. And for this first part of communication, so going from computer A to the switch, we're going to be using wireless or Wi-Fi. So we're going to be using some kind of wireless protocol. And that's going to be wrapped up. That's going to wrap up this entire packet. So there we have it. Here is our Wi-Fi packet, which inside it contains an IP packet, followed by a TCP, followed by the FTP, and then the data that we're sending. So we send this along to the switch. Now this is where the magic happens. This is why we talk about it in terms of layers. And this is why the application layer is at the top and our data link layer is at the bottom, or the outside of our packet, because as you can probably anticipate, this Wi-Fi packet is going to change depending on where we are in the network. So from point A to our switch, we're going to be using Wi-Fi, but for other parts of our network, we're going to be using some kind of wired protocol such as Ethernet. So let me just talk you through this. So we go from computer A to the switch. At this point, we remove the Wi-Fi packet on the outside, so we unpeel that layer. And we're going to put an Ethernet layer on the outside. And we're moving along this network now. So the things that go on the outside of the packet, the bottom layer, these are going to be things that are going to be changing the most frequently as we go around our network. So you're probably thinking, well, when does the IP address change? So the IP address is going to change by the time we get to this router. So by the time we get to this router, we're going to change the IP address. And bear with me while I fumble about in Paint, trying to get this working. It's going to be 192.168.1.3. Oh, so close. There we go, that's more like it. So there you go, so by the time we get to this router, the Ethernet has been peeled away and replaced with a different Ethernet layer, but also the IP address has been peeled away and replaced with a different one. And then this gets redirected up here. You're probably wondering, at what point do we remove the TCP layer and when do we remove the FTP layer? Well, in this example, they are not removed. And to be honest with you, they're not really swapped out that often when it comes to networking. However, there are some situations where they would be, just now I can think of off the top of my head. So going back to this diagram, the reason why we've got the layer model is because these two things at the bottom, they're on the outside of the packet, so they're at the bottom of the layer, outside of the packet, because they are stripped away and changed frequently as data moves around the network. These ones are at the top because they are in the middle of the packet. They're in the middle of the packet because they do not change very often as they move around the network. And in fact, for most cases, the application layer doesn't change at all.